This is the Aftermarket Radio Network.
Welcome, everyone, to yet another episode of Diagnosing the Aftermarket A to Z. I'm Matt Fonslow, and you spend your whole life looking for answers because you think the next answer will solve all your problems, make you a little less miserable. Because when you run out of questions, you don't just run out of answers, you run out of hope. That and more after a word from our sponsor, NAPA Autotech Training. Let NAPA Autotech's Build-A-Tech program, like Build-A-Bear, help you turn your general technician into a moneymaker for your shop. Make them a profitable member of your team. Go to napaautotech.com for more details. Okay, so for this episode, I guess it probably won't be as ranty as I want it to be, but I kind of want to go off on some of the stuff we get fed to us through various channels. And I guess I don't know if I really care to point out the specific channels. And it's certainly not related to just the topic I'm going to talk about. It's so many others. And it gets so rough talking about it because most of us can probably figure out who I'm talking about or what I'm talking about. And it just doesn't seem right to use this platform to call out specific entities or people about really, I don't know, misinformation, disinformation. Do you think really anybody's out there doing disinformation like on purpose to set us up for failure? I don't think so. I think it's misinformation and honestly, mythology. Some of you are probably guessing I'm going to go after catalytic converters, and I kind of want to, but honestly, I'm going to be doing something like that, a bit of a presentation for Scanner Danner for upload on his site. And so if you're interested in that, keep an eye out for that. I've been working really hard on it. It's just a really tough subject. And with my penchant for rabbit holes, I don't know that I'm hesitant with it too, right? I'm trying to pick a good path for it. So I'm not going to talk about catalytic converters today. I'm going to talk about EGR, exhaust gas recirculation. I think most of us are still operating under the, do I dare say, delusion? I don't know. I mean, we're taught what we're taught, and how are you going to ever disprove it? And why would you ever really disprove it? When are any of us going to be in a situation where we're going to care about this and use it to fix a car? I don't know. But it's also nice to know how stuff really works, or why we do stuff. And I guess, why car manufacturers, engineers, if you will, software writers, authors, programmers, why do they do the things they do? That's interesting because it kind of leads to the big picture of why our cars the way they are. Talk to most laymen and they think that the cars are far too complex, too many electronics, too much gadgets, too much junk, too much stuff to break. And yet in many cases, cars are better than they have ever been in the history. In some cases, some issues are easier to diagnose than ever before because of all the complexity. And then, of course, we have the few things that are wildly more difficult because of the complexity. EGR, I think we've been taught early on, is used to reduce NOx or NOx, oxides of nitrogen. And I have to be careful how I phrase this because I don't think we've been using EGR gases. And when I say EGR, I guess I want you to assume I'm talking about the gases themselves. We're kind of going through phases a little bit where there is an EGR valve, especially early on, we had EGR valves to route exhaust gases back into the intake and thus the combustion chamber. And now we do it more with cam timing, cam phasing, if you will, valve timing. That is how we're kind of keeping latent exhaust gases in the combustion chambers. And then yet some other vehicles, not a lot, but a few, we have both. The reason we are rerouting these EGR gases was because they're inert. Exhaust gases are inert. They're not going to burn anymore. By having them in the combustion chamber, it dilutes the air-fuel charge. And because it dilutes it, it lowers the combustion temperatures. And I say that on purpose because I think that's how it's been marketed to us, is the combustion temperatures. And that if we hit the magic number, we've been told that temperatures exceeding 2,400 degrees Fahrenheit. That's what's going to form these gases. I don't want to say that temperature is wrong, but I think when we talk about combustion temperatures, we forget what's going on in the combustion chamber. And it's not an explosion, right? When that piston starts to come up on top dead center compression and we start firing the spark plug, and of course I am talking very specifically about spark ignition engines. EGR gases are still extremely important for NOx control or NOx control on combustion ignition. Okay. So what I'm going to be talking about, I want to really just stick with spark ignition and leave compression ignition, diesel out of it. That inside that combustion chamber, it's not an explosion. It's a very controlled burn, or we want a very controlled burn. And when that spark plug fires and ignites that air fuel charge, we create a flame front. It's moving across somehow, if it's from the center of the combustion chamber out to the edges, or from one side to the other, or some variable of that. It's moving across. And it's that flame front temperature that's going to start creating the oxides of nitrogen. So if you can imagine in your head, instead of having this homogenized mixture of just air and fuel, we now have it diluted and molecules, if you will, broken up with inert gases. The temperature can't get as high. That makes sense. That's how they were controlling it, NOx production. But nowadays, we have so much better control over air-fuel ratios. And we have much better ways of bringing about that mixture, if you will, and making it combustible and delving into lean combustion or lean burn, if you will, or just leaner air fuel ratios that by themselves lower the temperature. So that brings about a myth that leaner burns hotter. Leaner air fuel ratios burn hotter. Well, what does leaner mean? If we just say leaner, it's running leaner. Leaner than what? Leaner than really rich? Like overly rich? Yeah, okay. Lean will burn hotter. Leaner than stoic? No, they do not burn hotter. Never have. Oh, well, Matt, that's untrue. I've seen engines that have been running lean and they burn exhaust valves. So yeah, they burn hotter. No, they don't. Exhaust temperature goes up. Because think about it. For the same reason we're slowing down and this will delve into another thing I'll bring up. I'll have to bring it up sooner than later. That flame front speed is slowing down because we have inert gases. Well, it's also slowing down because we don't have enough fuel with the, oxygen. Therefore, the temperatures drop. But because the combustion event takes longer, it happens and maybe even overlaps. And by maybe, I mean it does. Overlaps into when the exhaust valve opens and it starts just cooking the valve. It's a misnomer that leaner air fuel ratios burn hotter. No, they don't. They burn longer and into the exhaust stroke, starting with the exhaust valve opening, and it cooks the exhaust valve. It's not burning hotter. It's burning cooler. It's just when is it burning? And then what is it burning? In this case, an exhaust valve.
NAPA Autotech training sessions are being conducted day and night in a town near you. This training caters to every level within your organization, be it a mechanical assistant, a mechanical specialist, a technology specialist, or a driver safety calibration specialist. Imagine a one-stop shop training partner in NAPA Autotech that will lead your team to a path to greatness. Autotech's entry-level Build-A-Tech classes convert the untapped potential of your new hires into money-making mechanical specialists. Autotech's higher-level tech update classes introduce specialists to the world of ever-changing technologies, which prevents your shop from getting technologically stagnant. Remember, if you're not moving forward, you're falling behind. And, turning to the front of the store, the Autotech Service Advisor class is an awesome way to hone your client advocate skill set, ultimately benefiting the customer through an improved vehicle repair experience. But it doesn't stop there. Imagine an electric vehicle class that takes your specialist well past the mundane, yet necessary safety topics. Well, it's here. Autotech's EV Ready training is a week-long curriculum that takes participants through a hands-on experience involving hybrids and electric vehicles. The session kicks off with the use of PPE and proper tooling while touching on required OSHA regulations. Then, the students dive into the lab vehicles to gain knowledge of the common high-voltage components on EV and hybrid vehicles and their function. Attendees will be taken on a path exposing them to different electric vehicle manufacturers to compare component form and location. Additionally, information about Level 1 and Level 2 charging systems will be included, along with a quick look at DC to DC charging. The operation and maintenance of subsystems are explored, including the different modes of Tesla operations, and so much more. So what are you waiting for? Commit to taking your business to the next level with NAPA Autotech training.
So we can use air-fuel ratios to lower combustion flame front temperatures and reduce NOx production. So then why do we still use EGR gases? Why do we still use them? Okay, well, I've kind of given up the ghost a little bit with my last comment. One of the big reasons is slowing down that flame front, extending out how long that combustion event takes place, increases thermal efficiency of the engine, meaning it's burning for longer as the piston is being pushed down. You could argue that peak combustion pressures are lower, and they would be, but they go on longer. So we're getting more use of that, a longer push, if you will. That increases thermal efficiency. Exaggerated versions, which aren't necessarily related to EGR, but with valve timing, would be Atkinson's cycles, or even Miller cycles, which are kind of the same, but add a supercharger, if you will, or some boost. I think almost always supercharger. It's the same thing. We're extending how long that we get that push on the piston. That's an important reason why we have EGR gases, increasing thermal efficiency. Another big reason is throttling losses or suction throttling losses. One thing to try to grasp is that regardless of the engine size, it only takes X amount of horsepower, if you will, to move a car under varying conditions. It uses the same amount of air. And it might be slightly different due to moving parts, friction, if you will, stuff like that. It'll vary a little bit between like a 4-cylinder and an 8-cylinder, right? Of course. But honestly, it's the same amount of air, at least for the sake of discussion, without getting like super deep. And then the differences are going to be, I don't want to say negligible, but for lack of a better term, really, off the cuff, negligible. It's the same amount to move a V8 engine pickup truck down the road as it would a 4-cylinder or 6-cylinder pickup down the road. It doesn't take much. And one of the reasons, a 4-cylinder gets better fuel mileage going down the road is, it's got fewer cylinders, but also its peak horsepower is lower. Therefore, to make the same amount of horsepower, the throttle usually has to be open further. We can mimic that by introducing an inert gas. So now our peak horsepower drops with the same throttle position. What do we have to do? We need X amount of air to create X amount of horsepower to achieve, X amount of speed under whatever load. So then to meet that, we have to open the throttle more. What happens to intake vacuum, if you will, or intake pressure, if we want to speak correctly? What happens to intake pressure when we start opening up that throttle? Pressure goes up, vacuum goes down, which means the engine, if you will, doesn't have to work as hard to bring air into the cylinders. So right away, we get a nice efficiency boost. So it makes sense under a lot of conditions that if we can get as much EGR in and maintain combustion, the further open we can open up that throttle, the less throttling losses we have, the better, the more efficient that engine's going to be, the higher our fuel economy will. And fuel economy is a massive, massive interest because of not just CAFE standards, but CO2 emissions. We're going to reduce that by burning less fuel. So those are some really big reasons we're using EGR that I don't know how often I've ever been taught that. I had to learn that from, honestly, it was back in the day, it was IATN and reading and interacting with really, really smart people who dove into a lot of this. And some of them, it was part of their world. Like, again, Jim Kemper has been on the podcast. That was his world. That's what he dealt with for his job with the Colorado Department of Health, right? And kind of the emissions research lab, especially later on, Randy Burnclaw. This was right in their lap. This is what they had to deal with. And this is what we have a chance to read their stuff. And they have a lot of their stuff on diag.net. We're spoiled with this knowledge. And even if they didn't tell us exactly about it, pointing us in the direction to where to go get it, to kind of start winding this down. Another reason that we're starting to see EGR used, especially internal EGR, which would be via valve timing, cam phasing, is we're trying to get as much fuel economy as we can. If we can form a pocket inside the combustion chamber, so basically a pocket of space, we'll just say to the center for the sake of discussion of the combustion chamber, that this pocket of inert gas surrounding becomes a bit of an insulator between the combustion event and the cylinder walls. We want to reduce quenching. We want to reduce heat loss to the cylinder walls. It may not seem like a lot, but think about all the engines on the road. Every little bit adds up. It adds up. And again, more heat used to, if you will, at least for the sake of discussion, more heat used to push that piston down rather than being lost to quenching, the better. I don't know that I've ever read that anywhere, that they're doing that. And I guess I don't want to lie and say that it's well known. You know, if you want to plunk down a little bit of money, read into some of this stuff. There's a 2017 paper on lean burn SI engines, NOx control via air-fuel ratio modulation. There's impact of valve timing on cold start emissions in GDI engines. That's a 2019 paper. These are SAE papers. You'll find quite a few papers on the EGR forming a combustion pocket, specifically on like HCCI engines. And there's another one, it's 2009, with the effects of valve timing on residual gas and combustion and heat transfer in SI engines. So that's an important one. And then another one is the impact of variable valve timing on combustion and heat transfer in a controlled auto ignition engine, which is a little outside of what I'm talking about, but it does talk about how we're using internal EGR to kind of form this buffer, this insulation layer between our combustion event and the cylinder walls. And I just find that stuff fascinating. I don't know. I guess if anything, just appreciating or gaining more and more appreciation for what goes into the vehicles we're working on, whether we're working on them right now or we're going to be seeing them. And, you know, gosh darn it, not to just let your egos spin wildly out of control, but these vehicles you're working on, there's a lot of technology. There's a lot of complexity going on that we don't even know about. Nobody teaches us. And again, I don't know if anything I've just rattled off will help you ever fix anything. But I guess for me, it always felt better if I could understand what they're doing and why would help lead me to figuring out what's going on. Why isn't it working? Or even explaining why they do something or why they don't. Why would a software update fix this problem? If I don't know about any of this stuff, it would be a foreign concept. And of course, my example would involve catalytic converters, but I guess I have to save that for the Scanner Danner presentation, if you will. I hope you found that really interesting. You know, you guys ask for technical episodes. I think this is about as technical as it gets. Again, if there's topics that are of particular interest of yours, please don't hesitate to reach out. You can email me at mattfonslopodcast@gmail.com. Lately, I've been getting a lot of questions that are outside of automobiles or vehicles diagnostics, a lot of like personal type stuff. And I guess I'm thinking about doing another mailbag coming up here talking about things outside of just fixing cars. So yeah, don't hesitate to send me anything. I do respond to all emails as best I can. And if you have a topic you'd like me to cover, just shoot me that email or send me the instant message. And before I take off here, I really want to thank our sponsor, NAPA Autotech Training. And I would like to also thank the Aftermarket Radio Network and urge you to check out all the offerings that they have made available to us. So until next time, take care.
You've been listening to Matt Fonslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fonslow on social media and connect or on aftermarketradionetwork.com.